Hello everybody, this is Mr. Combs, and let's talk about the last stop on the factoring list, or the last stop we're going to talk about. So if we have a little review first, the factoring list. If you're going to factor a polynomial, the first thing that you need to do is you need to try to factor out the GCF. So after that, after you've factored out the GCF, or if you can't factor out a greatest common factor, then what do we need to do? Well, we need to look at how many terms we have. If we have 4 terms, then we're going to factor by grouping. If we have a trinomial, and it's of the form x squared plus ax plus b, where there's no number in front of x squared, well, we know there's a 1 there, but there's no number that's visible. Then we're going to write x and x in parentheses and fill in the blanks. If we have a trinomial and it does have a number in front of x squared, then what we're going to do is we're going to try to use trial and error. But the Z-box can help us. Can help us organize our thoughts. Okay? Let's consider something like this. What if I have y squared minus 4? Let's say I want to factor this. Well, if I look at the steps on the factoring list, factoring out the GCF, there is no GCF. Y squared and negative 4, or y squared and 4, they don't have any factors in common. I don't have 4 terms, so I skip steps 2. I don't have a trinomial, so I skip steps 3 and 4. But I do have a binomial, so step 5 will only be done if you have a binomial. And what you're going to do is you're going to look to see if your binomial is a difference of squares. Now, what is a difference of squares? Well, there's 2 parts of a difference of squares. There's the difference, and there's the squares. So if I'm looking at something like y squared minus 4, I'm having trouble today getting my numbers to form here. Y squared minus 4, the first thing you're going to look for is, do I have a difference? Do I have a subtraction? The next thing you're going to look for is, do I have 2 perfect squares? Are 4 and y squared something that we call perfect squares? Now, perfect squares are squares, things that are squared, that have a square root that is an integer, or a square root that's a whole number. So I'm not talking about decimals, okay? I'm not talking about decimals here. So a number is a perfect square if its square root is an integer. So not a decimal. Okay? So a number is a perfect square if it's integer, if it has an integer square root. Okay, a variable expression, let's see, where am I going to write this? I might go on to another page here. A variable expression is a perfect square if the exponent is even. Because if it's even, then we can break it up into two equal factors, right? So let's go back to y squared minus 4. This is a difference. Let's look at y squared. Is y squared a perfect square? Look at the exponent. Is the exponent even? Yes, so this is. We can actually break down y squared into y times y. So it has a square root of y. Alright, is 4 a perfect square? 4 can be broken down into 2 times 2, so it has a square root of 2, and 2 is an integer. It's not a decimal. It's not 2.3 or 2.5 or 1.79, so it is a perfect square. So I have a difference of squares. Y squared minus 4 is in fact a difference of squares. So how am I going to factor a difference of squares? So let's see. To factor a difference of squares, we're going to find the square root of both terms, and then after that we're going to use the following formula. If I have a squared minus b squared, then that's going to factor into a plus b times a minus b. So what this means for us is that if we have a difference of squares, we're going to find the square root of each term. What do we have to square to get each term? After that, we're going to take those two things, put a plus between them and a minus between them. So let's go back to y squared minus 4. And in this time, we're not going to worry too much about the sign that's in the middle. So we're not going to take this as a negative 4, to find the square root of a negative 4. And the reason why we do that is because, well, a negative number doesn't have a square root. So, you can't multiply two of the same things together and ever get a negative number, because two positives end up being a positive, two negatives end up being a negative. So we're not going to use that negative in this case. This is the only time that we don't use that negative when we're considering the term. But so what I like to do is I like to say to myself, what do I have to square to get y squared? What times what is y squared? Well, we saw on the other slide just y times y. And then now, what do I have to square to get 4? Well, 2 squared is 4. So now I have y and 2. I'm going to take y and add it to 2 per the formula, and subtract 2 from y. So this is the factored form. All right. Let's take a look at some expressions. When we look at these expressions, what we're going to do is we're going to determine if each is a difference of squares. If it's a difference of squares, we'll factor it. If it's not a difference of squares, we'll tell why it's not a difference of squares. So let's look at x squared plus 16. Is this a difference of squares? No. It's not a difference of squares. Why is that? Because of this plus. It's a sum of squares. And a sum of squares is not factorable in this class? We'll just say that. It's not going to be factorable in this class. You might take a class later on where that would be factorable, but it's not factorable now. Okay, let's try to look at another one. What about x squared minus 49? Well, it's a difference, so we've got that going for us. And what can I square to get x squared? Just x. What can I square to get 49? 7. So it is factorable, and it's factorable as x plus 7, x minus 7. And of course you could always write the x minus 7 first. Alright, let's try another one. What about 9x squared minus 76? Okay. It's a difference, so we've got that. What can I square to get 9x squared? Well, I can square x to get x squared, and I can square 3 to get 9, so 3x squared will be 9x squared. What can I square to get 76? Is there any whole number or integer that I can square to get 76? I don't think so. So 76 is not a square. We'll say a perfect square. So we have to say that this is not factorable. Alright, let's try to factor some others. What if I have negative 49 plus t squared? This one's sort of tricky, or it's trying to be tricky, but we can easily fix it. Doesn't look like it's a difference of squares now, right, because I have that plus in there. But if I take this t and rearrange it with the negative 49, I'll have t squared minus 49, and I think we know how to factor that. What do I square to get t squared? Just t. What do I square to get 49? Just 7. So t plus 7, t minus 7. What about 64 x cubed minus 36x? Alright, so 64x cubed minus 36x. What do you notice? Well, in this case I notice that 64 and 36 are both divisible by 2, I know. Let's see, I think they might both be divisible by 4. Yeah. So they're both divisible by 4, so they have a factor of 4, and I have an x in both. So I'm going to take a 4x out of there. So even before we can start using steps 2, 3, 4, or 5, we have to apply step 1. Sometimes that'll happen. So 64 divided by 4 is 16. And I'm left with x squared because I took one x out. Minus 36 divided by 4 is 9. Now I'm going to try to see if I can factor 16x squared minus 9. It is a difference. It's a binomial, so I'm going to see if it's a difference of squares. So it is a binomial. I mean, we've established that. It is a difference. Let's see. 16x squared. What is the square? Or what do I have to square to get 16? 4. And what do I have to square to get x squared? X. And what do I square to get 9? 3. So 4x, let me write it up here, plus 3 times 4x minus 3. I know what you're thinking. I can't forget about this 4x on the outside. So 4x times 4x plus 3 times 4x minus 3. And that's it. Okay. What about this one? (25x squared minus 4y squared). Well, it's a difference. And what do I have to square to get 25x squared? 5x, right? What do I have to square to get 4y squared? 2y. So this is going to be 5x plus 2y, 5x minus 2y. So that's not so bad. Okay, let me let you try these on your own. We'll try p squared minus 9, negative 64 plus m squared. Let's try 81x cubed minus 16x. Let's try 16a squared minus 9b squared. And let's try 8x squared minus 98. Let me write that a little bit lower. Alright, so what I would like for you to do is pause the video and try to work through these, and then we'll work on them together. Okay, I hope that you have worked on these. If you still need extra time, go ahead and pause that video again and then work some more, and then we'll work on them. But we're going to start looking at the answers now. So in this case, I have p squared minus 9. It's a difference. It's a binomial, so there's nothing in common. So I'm going to factor it as a difference of squares. So what do I square to get p squared? Just p. What do I square to get 9? 3. So the factored form is going to be p plus 3, p minus 3. And that's it. If I'm looking at negative 64 plus m squared, really I need to fix that one or switch it around. So I'm going to switch it around to m squared minus 64. That becomes easy then. M squared is how I get m squared. And 8 squared is how I get 64. So this is going to end up being m plus 8. M minus 8. I think a binomial that's a difference of squares is one of the easiest things to factor, to be honest. Alright, let's look at 81x cubed minus 16x. 81 and 16, I wonder if they have any common factors. I don't think so, but I do notice there's an x in both of these. So I'm going to take that x out first. So I'm going to have 81x squared minus 4. I'm sorry, I don't know what's going on in my brain. Minus 16. Because all I did was take an x out of there. Okay, so 81x squared minus 16. What do I square to get 81x squared? Well, 9 times 9 is 81, and x times x is x squared, so it's 9x. And what do I square to get 16? 4. So this is going to be 9x plus 4, 9x minus 4. And you know what? I can't get forget about my little buddy x there, so x has to come over, and this is the full factored form. Go over here and box that one in too. 16a squared minus 9b squared. Nothing in common. I have a binomial, so what do I square to get 16a squared? Well, that's going to be 4a. And what do I square to get 9b squared? That's going to be 3b. So this is just going to be 4a plus 3b, 4a minus 3b. Alright, and then let's look at this last one. 8 and 98. I know that they have a factor of 2. I don't think they have a higher factor, so I'm going to take a 2 out. 8 divided by 2 is 4x squared. Well, 8 divided by 2 is 4, and then I have an x squared. And 98 divided by 2 is 49. So 4x squared minus 49, it's a binomial, so I'm going to check to see if it's a difference of squares. It is a difference. 4x squared, I have to square 2x to get that, and I have to square 7 to get 49. So this is going to be 2x plus 7, 2x minus 7, but I can't get rid of my 2 there on the outside. So that is the full factored form. Let me also get this one in there. So there you go. I hope this helps. This is the last step on the factoring list for our class. All right.